Today we will do differentiation. We will show differentiation P2. So that's P2 differentiation. Now this chapter, which is okay. This chapter is divided into two parts. The chapter is divided into two parts. First of all, in the first part, it talks about increasing and decreasing intervals, and how we used to find them for any function without drawing, how to find the increasing and decreasing intervals. Now then it talks about how to find the stationary point. And what do you mean by stationary? Either maximum or minimum for any function. How to find the stationary points. Number 3, how to justify that this stationary point is a maximum or minimum. How to justify or either maximum or minimum, justify proving that or minimum by using the second differentiation. Okay, now this is the first part of this chapter, and it also talks the, let's say, number 4, the graph of the function fx and the differentiation of the function, the graph of the differentiation. Here we are dealing with f prime x as an individual function away from fx. Now the second part, real life situations, real life problems, which is applying differentiation into real life situations for volumes, surface areas, and so on. So we will start doing this, the revision. I'll start doing the revision by the beginning of this chapter, and we will then solve past paper questions using this. Now to continue my video about revision for differentiation P2. We know how to differentiate. Now what is the significance of differentiation? To find the stationary points. كلمة stationary, the word stationary points means where if we draw a tangent, we will draw if we draw a tangent at those points. For example, there is a tangent and there is another tangent. That's where the tangent is parallel to the x-axis. That's called the stationary point, where we have, as you can see, maximum and minimum. This is the case if we have a graph for the function, if we can plot the graph. But this is useful when the differentiation is equal to 0. For any function we cannot plot the graph for it, so we have a stationary point. As we can see, there is a maximum or minimum. Some function we cannot sketch, we cannot draw. So finding the differentiation and equating the differentiation to 0, this means that there is a stationary point without graphing. I have given the example that we can see and we can apply on differentiation. What do we know? Now, first of all, I would like to revise the increasing and decreasing interval for a function. As you can see, this is a very well known way how to sketch the graph of a cubic. As you can see, it's increasing on the left hand side of x equals negative 0.7. That's a negative 0.78 on the left hand side. It's a decreasing. Then between this value of x, negative 0.7, and this value of x, 2.412, now this function is decreasing, okay, and then it's again increasing. So finding the increasing and decreasing intervals without seeing the graph, first of all, let's differentiate dy over dx, and let's equate this to 0. So we will get 3x squared minus 4x minus 5, and put this equals 0. Why is that? Because we need to find out those 2 points, those stationary points. Now we may say that by using the general formulas, we find out that x equals x1, that's a negative 0.786, and x2 is equal to 2.12, okay, by using the general formula. So that quadratic, which is the differentiation, has zeros, this value and that value, which they are the stationary points. Those are called stationary points, okay. So stationary points where the differentiation is equal to 0 for this function. Now finding increasing and decreasing intervals, we will plot a straight line and we will put the zeros of that quadratic function 8x and the other 2.12, and then we will choose points between those values. Let's say I'll choose 3, I'll choose 0, I will choose negative 1, and let's do substitution with the differentiation. Why is that? Because we want to see the sign of the differentiation, is it positive or negative. So substituting negative 1 in the differentiation, that's positive, we'll get positive value, then the 0 negative, then positive. Means that the function on the left hand side of negative is increasing, and the function between those two values decreasing and increasing, and this shows from the graph. طبعا احنا في الأسئلة ما عندنا graph, we don't have graphing for the functions in our questions. Sometimes it's a very complicated function, so finding an easier way than graphing to find the maximum or minimums, or to find increasing decreasing intervals, it's easier by using differentiation. Now this is how to find. So we say that it's increasing function where x is less than negative 0.786, or it's increasing where x is greater than 2.12, and if the function is decreasing when x is between the two values negative 0.786 and 2.12. That's about increasing and decreasing intervals.